This video is for Algebra 2, quiz 1.5.3. It'll be due on Friday, April 17th. There's a couple things that we need to go over, just a little bit of vocabulary here. Literal equations are equations that have more than one variable. So that's an equation something like this one here. Here we've got an x and a y. This equation has three variables, d, r, and t. This equation down here has 2, x and y again. So a literal equation is just an equation that has more than one variable. And there are steps to solve these literal equations. These are general steps. But the first general step is you want to isolate the term that has the variable that you're looking at. So in this first problem here, we're going to be solving for x. So what that means is we want to isolate this 3x on one side of the equation. So that's the first general step of the problem. The second general step is then to use the algebra rules to remove everything off of the variable. What I mean by that 3 is on the x. The 3 is multiplying the x. So once you get the 3x isolated, you still have to remove the 3 from the variable. So okay, let's go ahead and see how we solve this problem. This is 3x minus 4y is equal to 16, and we're going to solve it for x. So what we're going to wind up with is x equals something. And that's what we want to find out. That'll be the solution. So the first step is to isolate this term, the 3x. That's the one that has the x in it that we're looking at. So we want the 3x to be on one side of the equation all by itself. It doesn't matter which side, as long as it's all by itself. We can achieve this by taking this negative 4y and moving it to the other side of the equation. Now we move it to the other side of the equation by adding 4y to both sides. Whatever this operation is, you do the opposite. So the problem, it has a subtraction with 4y, so we're going to do the opposite. We're going to add 4y, and we're going to do that to both sides of the equation. So we add 4y to this side, and we add 4y to this side, to the right side. On the left-hand side, these will cancel and go to 0. And so the 3x just comes down by itself. The equation then just drops down. There's the equal sign. Here on the right-hand side, we have 16 plus 4y. You can't directly add these two together because this has a variable on it and this does not. So you just write them together. We're going to just have 16 plus 4y. Usually you write the variable first. So we're going to have 4y plus 16. Like that. So now we have isolated the term that has the variable in it. The 3x is now by itself on the left side of the equation. Now we just need to remove anything else that's on the x. The 3 is on the x, so we need to remove that. We want the x to be completely by itself. So since the 3 is multiplying to the x, we do the opposite operation. We're going to divide by 3, and we have to do that to both sides of the equation. So we're going to divide by 3 here on the x. And now whenever you divide by 3 on the right side, we're dividing the entire side of the equation by 3. So the entire side gets divided by 3. So here these 3's will cancel. And you'll just have x left by itself. And the right side, there is not a way to simplify this. So it's just going to get rewritten. It's going to be 4y plus 16, and then all divided by 3. Now, you can separate that fraction where there's addition here in the top. You can separate that fraction over that addition and write it this way. So we're going to separate the 4y and the 16. And you still write it over the same denominator, over 3. So all we did was separate the 4y and separate the 16 where there was addition. You can do that with subtraction also. Now, either way, whether you write it this way or whether you write it this way is correct. So if the computer has either answer, you want to pick the one that you want to pick the answer that's displayed, the correct one. Okay, so now let's look at this problem. Here we don't have any numbers. It says we're going to solve d is equal to RT, and we're going to solve it for t. So that means we want t to be on one side of the equation all by itself. Now, even though there's no numbers at all in this equation, all of the algebra rules still apply. You just apply them to the variables. The t is already isolated by itself. What I mean by isolated is there's no addition or subtraction. So up here, we have 3x minus 4y. We needed to get rid of that minus 4y. There's no like plus something else or minus something else here on this right-hand side. So that term is isolated. The t is isolated. We do, however, have to get rid of the r. We just want the t to be completely by itself. The r is multiplying to the t. So to undo that operation, we need to do the exact opposite. We need to divide both sides by r. So we divide this side by r, divide the left side by r. When we do that, these r's on the right side will cancel. And so you'll just have t that's left all by itself. And on the left side, you have d over r. And once we do that, we're completely done. The t is isolated. It's all by itself. There's no way to reduce this d over r. So that's it. The problem is finished. You stop right here. The t is isolated, and there's no way to simplify the other side. So that is the answer to the problem. So all we had to do was divide both sides by r on that problem. Okay, let me show you another one here. Here we have another equation where we have y is equal to x squared plus 7, and we want to solve for x. So we want this x to be all by itself. Just coincidentally, this equation is already solved for y, because y is by itself, and there's no y's over here, so we have y is equal to x squared plus 7. So that equation, the way it's written, is already solved for y. However, the problem says we want to solve for x, so we need to have x equals something. So the first thing we do, again, the very first general step is to isolate the term that has the x in it. So this x squared term, we want to be by itself on one side of the equation. So we need to get rid of this 7 here, this plus 7. So we're going to do the opposite to both sides. We're going to subtract 7 from both sides. So subtract 7 here on the right side, subtract 7 here on the left side. Now on this left side, you can't combine the y and the 7 because this is a variable, this is the number. So again, you just write them out beside of each other. This is just going to be y minus 7. The equation, the equal sign just comes on down. On the left side, nothing's being done to the x squared, so it just comes on down. Excuse me, on the right side. Also, you have 7 minus 7. That becomes a 0, so there's nothing that gets written here beside the x squared. So now we have y minus 7 is equal to x squared. Our x term is isolated. Now we just have to remove anything else that's on the x. That square is on the x, so we do have to remove the square so that we just have x by itself. Now, in order to get rid of the square, you have to undo that operation. So instead of squaring, we're going to take the square root of both sides. So I'm going to use the square root symbol, take the square root of the left side. So we have the square root of y minus 7. And then we take the square root of x squared. Now you've got to be very careful. Whenever you write the square root symbol into a problem, you have to put plus or minus on it. And the side that you put plus or minus on is the side that's opposite the variable that you're solving for. So we're solving for x, so the plus or minus goes over here. So we're going to have a plus or minus in front of this because we wrote the square root on the into the problem ourselves. Now we just need to simplify a little bit. This square root will cancel the square on the x, so that will just make x be all by itself. On the left-hand side, there's nothing to do. There's no way to take the square root of y minus 7. There's nothing you can do with the plus or minus, so it gets rewritten. And again, simplifying this side, taking the square root of x squared, the square root will just cancel the square, and you're just left with x. So now we have x is all by itself, and there's nothing you can do to simplify the other side. So that is the answer to the problem. Let me back out. Now let's see the whole page here, so you can pause it if you want to. But that's really it for the lesson, guys. You just want to isolate the term first of the variable that you're solving, and then get rid of anything else that's attached to that variable. Just let me know if you have any questions.